Assalamualaikum and hi to everyone. Thank you for watching this video. The previous video we already discussed about the analog signal. What are the characteristics of the analog signals? Okay, so in this video we will talk about the digital signal. So the digital signal always represent a data in 0 and 1 voltage. Okay. These are two type of digital signal. At the first graph, we have a digital signal with two level. So this one is the first level and this one is the second level. So at this point, it contain only one bit. So this signal is in 1 second. So in 1 second, it contain of 1, 2, 3, 4, 5, 6, 7, 8. 8 bit of data. So that means in 1 second, this signal send 8 bits of data. So the bit rate is 8 bit per second. Okay, it send 8 bit in 1 second. So the bit rate is equal to 8 bit per second. For this graph, okay, this graph we have 4 level of signal. The digital signal with 4 level. So at each level it send 2 bits of data in 1 second. Okay, this one is in 1 second. It send 16 bit of data. So that means the bit rate is equal to 16 bit per second. In 1 second, this signal allow you to send 16 bit of data. So that's are the difference. Okay. So example here, let's say a digital signal has 8 level. How many bits are needed per level? So we calculate the bit based on the formula log 8 base 2. Okay, so number of bits per level is equal to log number of data level, log number of data level. So in this case, the signal level is 8. So log 8 base 2 equal to 3. So 3 is referred to bits needs per level. So that's mean, okay, based on this graph, okay, bits per level is equal to 3 if we have 8 level of data signal. Okay, another example here. A digital signal has 9 level. Okay, number of level in a digital signal, it has 9 level. How many bits are needed per level? So we can calculate using the formula using log number of level base 2. So each signal is represented by 3.17 bits if we use that formula. Okay, however, this answer is not realistic because we can have 3.17 bits. We only can have a disk value of data of bits number. So the number of bits sent per level need to be an integer as well as a power of 2. Okay, for this example, 4 bits can represent 1 level. This one is not logic, not realistic because we discussed about the digital data. So we can assume that 1 level is equal to 4 bits. Okay, example 3. Assume we need to download text document at the rate of 100 pages per minute. Okay, assume we want to download text document at the rate of 100 pages per minute. What is the required bit rate of the channel? Okay. So a page of a text document is average of 24 lines with 80 characters in each line. Okay, assume that in one page we have 24 lines with 80 characters in each of the lines. So we assume that one character requires 8 bits of data. So the bit rate is 8 bit of data. Okay, 100 pages times with 24 line times with 80 character times with 8 bits. So it equal to 1,636,000 bit per second, and then we can change into the megabit per second. So this is how we calculate based on the assume one character equal to 8 bit. So you have 100 pages, one pages have 24 line, one line we have 24 line with the 80 characters. So we need to time with 80 characters, and then each character we assume that it has 8 bit, so we time with 8. So this is the bit rate of the channel. Another example, okay, when we do digitized voice channel, it is based by digitizing a 4 kHz bandwidth analog voice signal. So we need to sample the signal at twice and highest frequency. 2 sample per hertz means double it the highest frequency. So we assume that each sample require 8 bits. What is the required bit rate? So we need to identify what is the bit rate. So the bit rate can be calculated as 2 times 4000. This one is kilohertz. So kilohertz change to hertz, 4000 hertz times with 8 bit. So we get 64,000 bit per second. And then we can change into or do conversion to the kilobit per second. Okay. The next point, okay, this we have a signal, digital signal. The first one is in time frequency domain. This one is time domain. This one is the frequency domain. Okay, the next part we have time and frequency domain of non-periodic digital signal. This one is periodic. We have a pattern here. So when we do convert into the frequency domain, it look like this one. Okay, this part is the time and frequency domain of non-periodic signal. So when we convert into the frequency domain, it look like this one. We have the highest frequency and we have the lowest frequency. Okay, the next video we will discuss on the broadband and baseband transmission. So please click on the next video. Don't forget to subscribe, like and share.